Right then, a short little video on factorising expressions. Looking at page 77, section 5.5, starting at grade D and staying at grade D. It says factorise the following expressions, going to question 2. I've got 2a plus 4. Now, imagine there was a bracket there before we broke it all open. What might it be? Well, look, if we take the common factor of 2a and 4 out, where the common factor is 2, and what might have gone in the bracket? Well, to get 2a, there had to be an a right there, and to get a 4 there had to be a 2 there. Let's just see why. Right, 2 times a is 2a, that's good, and 2 times 2 is 4, so therefore we know that we factorised it correctly. So 2 is a factor of 2a plus 4, and a plus 2 is also a factor of 2a plus 4. We have factorised that expression. Let's pick a dodgier one, only slightly. I've got 5c minus 10. What was that before it was broken open? What was that before we busted open the brackets and released the two terms? Well, I reckon the common factor of 5 and 10 is going to be 5, and the question is 5 times what makes 5c? Well, 5 times c makes 5c. Put a minus there because it's going to be negative. 5 times what makes minus 10? Well, 5 times minus 2 makes minus 10. These are the factors of that expression there on the left. Next one, I've got 12 minus 2f. I'm not doing them in order, I'm just doing them just down the page. What is the common factor of 12 and 2? Well, 2 is the biggest factor I can take. 2 times what makes 12? 6. 2 times what makes 2? Just 1 on its own. So I've got minus f there. Let's just look at it. 2 times 6, 12. 2 times minus f, minus 2f. So that's correct. Let's just look at H. H says this: 8j's take away 2k's. What's common? I can take an 8 from that one, but I can't take an 8 from that. The biggest I can take is 2. So I'll take a 2 out of each of you. So that will leave me with 4j's inside, because 2 times 4j makes 8j. And 2 times a single k will give me 2k's, but it's negative. 2 times minus k makes minus 2k. So that's correct. Let's just try this one over here. I've got x squared minus 7x. Where we're going to go with that? Oh, should put equals there. The common factor is x from u and x from u. If I've got an x squared, then I make it by going x times x. So if I can take an x from each one, I'm left with this. X times x makes x squared, and x times 7 will make 7x, but of course it will be negative because it's negative right there. Let's just test it. X times x, yep, x squared. X times minus 7, minus 7x, so that's good as well. Y squared plus y, factorising. Clearly the common factor is going to be y. Get your bracket ready. How do you get y squared? Well, it will be y times y, and y times what makes y? Well, y times 1 makes y. So I'd definitely learn that one if I were you, because kids tend not to like to leave a 1 there. It just seems so out of place. But look, y times 1 makes a single y. Try n now. We have got 3z squared plus 4z's. Right, I can't take 3 and a 4 as a common factor. I haven't got one. But I can take a z from that and a z from that. Therefore, the highest common factor will be z. Take it out. That'll give me 3z's left inside, because z times 3z makes 3z squared, plus 4, because z times 4 makes 4z's. Alright? Let's have a look at a more challenging one. I think I'll try Q. Q says this. It says 2d squared plus 8d. Now I like this one because I can take a 2 from a 2 and a 2 from an 8. I can take a d from a d squared and a d from a d. So the biggest I can take is 2d. Let's worry about what goes inside now. 2d times something makes 2d squared. Well, I'll require another d. 2d times d makes 2d squared. 2d times what makes 8d? Well, I need a 4 there, because 2d times 4 makes 8d. And this is called factorising fully. Alright? Now, how do you not factorise fully? Simply, if I just took out the 2 alone and ignored the d squared would be in there, and the 4d would be in there as well. Not good. So I've got to take the most that I can. I'm going to take a 2 from each and a d from each, and therefore the factors I get outside of the bracket are the biggest I can take, the most I can take. So to factorise fully, take the most you can from each of the numbers if they're there, and the biggest power of each of the letters that you've got there. Alright, so that's factorised fully, and in an exam it may say factorise this expression fully. The hint is you can take more than one thing out. Alright, what else we got here? I'll do the last one and move on to question 5 maybe. Anyway, 6y squared minus 3y plus 9xy. Plenty going on there. Right, what's in common? 6, 3, 9. Right, look at the numbers alone. I can take a common factor of 3 out. A y squared there, a y there, and a y there. Oh, I can take a y out as well. X with a 9xy. Can't do anything with that because the other two terms do not have an x in them. So the biggest factor I can take out of each of these three terms is the 3y. I'm about to factorise fully. So open up my bracket and right, 3 times 2 makes 6. He's happy. And y times y will make y squared. Therefore the term inside the bracket first is 2y minus, well, 3y times 1 will make minus 3y. Sorry, 3y minus 1, when you multiply it, will give you minus 3y. And for the final term, 3 times 3 makes 9, so that's 3 there. And I require an x, and it's positive. 3 times 3 gives me the 9. Y times x gives me the xy part. Altogether, I have 9 lots of xy, and that's exactly what I've got outside. Alright, so that's fully factorised. Go over one more time. 3y times 2y, 2 3s are 6, y times y, y squared. This next one here, 3y times minus 1, straight away minus 3y. 3y times 3x, or 3 3s are 9. X times y is just xy, and it's positive. Alright, so I'll go back to my original answer there. And what else have I got here? Question 7 says factorise each set to find the odd one out. Well, I'll just do one of these anyway, and then move on. I'll do the last one, which is 5c. So I've got 6p squared plus 4q squared. Then I've got 6p plus 4q, and I've got 3p squared plus 2pq. We'll factorise them going down the page, then we'll see which claims to be the odd one out. Okay, let's factorise fully. I can take a 2 out of that and a 2 out of that and absolutely no more. So the biggest factor I can take is a 2. So bracket plus a plus. 2 times 3 will make 6, and I'm left with p squared. 2 times 3p squared, 6p squared. Likewise, taking a 2 out of the 4, I end up with a 2q squared inside. So 2 times 2q squared is 4q squared, and that's the most I can do with that. Taking this one, the expression is going to be the maximum I can take out of 6 and 4 is 2 again. So 2 bracket, that'll give me 3p, 2 lots of 3p is 6p, plus 2q, because 2 lots of 2q is 4q. So that one's factorised. Now here, what can I do? I can't take a 2 out of that. I can only take a 2 out of the 2. So the most I can take really is to take a p out of the p squared and a p out of the 2pq. So here we go. P bracket, close bracket, plus in the middle, because it says so. So p to 3p squared requires a 3p inside. And this one here, if I take out a p, I'm left with 2 times q, or 2q. So let's just test it. P times 3p, 3p squared, yep. P times 2q, 2pq. We write it that way around because p becomes it comes before q in the alphabet. Now, what we got in common here? Right, I reckon, well, there's 2 reasons actually. Let's just take a look. These have got a common factor of 2 each and no more. These have got a common factor of 3p plus 2q each. So factorise each set of expressions to find the odd one out. Let's just check I've not overlooked anything. take a 2 out of that and no more. Yep, 3p squared, 2q squared, and then take a 2 out of each. That's good, and then take a p out of each. Which is the odd one out, actually? Honestly, I don't know. I have a 2 and a 2. I suppose, actually, this could be the odd one out. I'm just thinking out loud here. This could be the odd one out because it has no numerical factor. Well, these ones are numerical factors. In other words, factors, real numbers, okay? That hasn't got any. So I suppose we can do that. But incidentally, that was a little bit tricky because I got 3p plus 2q there and 3p plus 2q there. I might have called that one the odd one out. But I suppose looking at it its most simplest level, the odd one out will be the last one because it's got no numerical factors on the outside of the bracket. So that's that. And I'll stop the video now and I'll see what's worth doing in the assess.